Now, next topic, that is electric flux, but electric flux we will discuss later on. First, we will discuss the topic, next one to it, that is electric dipole. Now, what is electric dipole? Electric dipole is a system of two equal but opposite charges separated by some finite distance. Now see here, as shown in this figure, suppose we have a system of two charges equal in magnitude but opposite in polarity. So one charge is plus Q, another one is minus Q. And these two are separated by some finite distance to A. Then this particular system, that is called electric dipole. Di means two poles, right? One positive, another one negative. Now, with respect to the center of dipole, we consider positive charge and negative charges are at a distance A on either side, and this total distance between two charges, that is represented by 2A. Here one very important physical quantity is defined for dipole, and that is electric dipole moment, right? Now electric dipole moment, that is the vector quantity, and that is represented as P equal to Q into 2A. Its unit will be coulomb into meter, and the direction of electric dipole is always represented from negative to positive charge. It implies that it is in the direction from negative charge to positive charge. Clear? Now suppose here we take the magnitude of the charge that is too much large. Means if we take limit Q tends to infinity, and if the separation between these two charges that is very small, means limit 2A tends to 0, then in that particular case we can say the electric dipole, that is a point dipole. That is the point dipole. So this one is the concept of electric dipole. Now we have to derive the equations for electric field of electric dipole. Here see, the net charge on electric dipole, that is equal to 0, because net charge, that is the algebraic summation of the charges. So for this system of two charges, both the charges are equal in magnitude but opposite in polarity. So if we take the algebraic summation, then net charge will be 0, but net electric field of electric dipole, that will not be 0, right? So here now we have to discuss the electric field of electric dipole. Clear? Now here we have to find the electric field of electric dipole at any point on the axis of the dipole, as well as at any point on the equatorial line of the dipole or equatorial plane. Say, the axis of the dipole, that is the axis passing through both the charges, this one, that is called axis of the dipole. And the equatorial line, that is passing through the center of the dipole and perpendicular to the line joining to these two charges, means here. Okay, so we have to find the electric field on the